You know, usually when we talk about a medical diagnosis, there's this expectation of absolute precision, like engineering.
Right, like it's a binary thing.
Yeah, exactly. You break your arm, the x-ray shows that jagged white line, and the doctor just points at it and says, there it is.
It's broken or not broken. It's clean and undeniable.
We really like things to be visible, to be categorized. We like to know that a problem has a specific, locatable physical reality that we can just point a finger at.
It's comforting.
It is. But what if I told you that if you zoomed in close enough on that x-ray, like close enough to see the actual atoms making up the bone completely disappears?
The whole machine breaks down.
Right. The solidity just vanishes entirely.
You basically step out of that comfortable, pointing at an x-ray reality and into something incredibly fluid and honestly mind-bending.
So welcome to the deep dive. Today, we are looking at Fritjof Capra's groundbreaking 1975 book, The Tao of Physics. And we're exploring why the most advanced particle accelerators in the world are essentially proving ancient Zen masters right.
Which is still such a wild concept.
It really is. Our mission today is to explore this astonishing, deeply humbling parallel. We are taking the rigorous, mathematical, highly technical realm of modern subatomic physics, and we're placing it right next to the ancient, intuitive, spiritual wisdom of Eastern mysticism.
And it remains, one of the most remarkable convergences in intellectual history.
Truly.
When Capra's book came out, it sent massive shockwaves through both the scientific community and the general public.
Yeah.
Because it dared to suggest that these two radically different ways of looking at the universe, physicists in lab coats analyzing quantum fields on one hand, and sages in meditation decoding ancient texts on the other, they're actually looking at the exact same underlying reality.
And arriving at the exact same conclusions. That is the part that just fundamentally shatters how you view the world.
Yeah, it completely rewrites the rules.
So whether you are prepping for a high-level science class or exploring spirituality or just, insanely curious about what reality actually is, this material will change how you view everyday objects.
To set the stage for you, I want you to imagine the space we are exploring today as a massive room split perfectly down the middle.
Okay, I'm picturing it.
So on one side, you have a library of dense, peer-reviewed scientific journals, whiteboards covered in Schrödinger's wave equations, the hum of supercomputers.
Very clinical.
Right. And on the other side, you have a serene Zen garden, the smell of incense, and the quiet stillness of centuries of uninterrupted meditation.
Complete opposites.
Or so we thought. What we are doing today isn't just reciting cool science facts. We are charting a massive paradigm shift. We are looking at how the whiteboard and the Zen garden are not opposites at all. They are reflections of the exact same truth.
Okay, let's unpack this. Because to understand how radical this shift is, we really have to understand the starting point. We have to look at how we got so utterly obsessed with the X-ray view of reality in the first place.
The need to dissect everything.
Exactly. Why do we assume the world is made of solid, separate things? Capra frames this as the Great Divorce. It's the story of how Western culture basically lost the wholeness of the world.
And to find the origin of that divorce, we have to rewind the clock all the way to ancient Greece.
Let's go back.
When we trace the roots of Western science, we typically land in the 6th century BC in Ionia with the Milesian school of philosophy.
Okay, so thinkers like Thales, Anaximander, Anaximenes.
Yes, those guys. And if you were to speak to one of these philosophers, they wouldn't even understand our modern separation of disciplines.
Like if you asked them, hey, are you a scientist, a philosopher, or a priest? They would look at you like you had 3 heads.
Totally. Because for the Milesians, there simply was no distinction between science, philosophy, and religion. They viewed the universe as a singular, living, completely interconnected organism.
So they didn't look at a tree and see dead matter interacting through blind mechanical forces.
Not at all. They saw a world infused with breath, with life. They used the word physis to describe this fundamental interconnected nature of all things.
Physis, which is literally where we get the word physics.
Exactly.
But the original definition wasn't about, calculating the trajectory of a cannonball.
No, the root of physics was originally this concept of organic, living, interconnected wholeness. They believed that everything from the stars in the sky to the dirt under your feet to human consciousness itself was fundamentally a manifestation of the exact same living essence.
I know Thales thought this ultimate essence was water, right? And Anaximenes thought it was air.
Right, but the specific element they chose mattered way less than the underlying concept, which is that the universe is one living thing.
So if we started out with this beautiful, holistic, interconnected view of the universe, what happened?
Things took a sharp turn.
Yeah, how did we end up with the highly fragmented, highly clinical version of science that has dominated the last few centuries? Where did the Great Divorce actually occur?
Well, the fracture happens a bit later in Greek philosophy, primarily driven by a thinker named Parmenides and the Eleatic school.
Okay, what was his deal?
Parmenides was wrestling with a huge philosophical problem, which was the problem of change. He thought, if ultimate reality is eternal and perfect, how can things in the world constantly change and decay?
Oh, I see.
To solve this, he introduced a concept that was intellectually really powerful, but, as Capra argues, spiritually devastating. He separated reality into two distinct realms.
He literally chopped the universe in half.
He did. He proposed that there was an eternal, unchanging, indestructible realm of being, which we might call spirit or divine intellect. And then there was a separate, changing, temporary, illusory realm of the physical world.
This is the critical moment, isn't it?
It really is.
Because once you separate spirit or mind from matter, matter becomes something lesser. It loses its inherent life.
It becomes a dead object to be manipulated.
Right, rather than a living system you are intimately a part of.
And that philosophical wedge paved the way for the man who really sealed the deal for Western science, which was Democritus.
The atom guy.
Exactly. Democritus took this concept of dead matter and introduced atomism. He argued that all of reality is essentially just a giant empty void filled with countless tiny, indivisible, unchangeable dead particles. He called them atomos, meaning uncuttable.
You know, here is how I picture this shift. It's like we started out looking at reality as this incredibly complex, beautiful, living ecosystem, like a sprawling rainforest.
I love that analogy.
Everything relies on everything else, you know? The soil needs the rain, the plants need the soil, the animals need the plants. It's one breathing entity.
It's all connected.
Yeah, but then Greek philosophy came along and essentially turned that entire living rainforest into a giant, endless bucket of Lego bricks.
That captures the conceptual shift perfectly.
We started believing that if we could just pull every single Lego brick apart, categorize it by color and size, and lay them all out on an infinite table, we would somehow understand the rainforest.
Which is absurd when you think about it.
It is. We convinced ourselves that the secret to the universe wasn't in the interconnected web, but in the individual dead building blocks.
And that Lego brick mentality is what laid the foundation for the entirety of Western scientific dominance for the next 2,000 years.
It became the default operating system for the human mind in the West.
Yes. And it reached its absolute peak in the 17th century with Isaac Newton and the mechanistic worldview.
The famous clockwork universe. Let's talk about how Newton formalized this, because he took Democritus's philosophy and gave it teeth with actual mathematics.
He really did. Newton gave us a mathematical framework, calculus, and the laws of motion that perfectly described a universe of separate, solid objects interacting through invisible forces, primarily gravity.
Right.
In the Newtonian worldview, the universe is quite literally a giant lifeless machine. God wound up the clock at the beginning of time, and now it just ticks away with cold, deterministic mathematical precision.
It's incredibly deterministic. The logic goes that if it's a machine, you just need to understand the gears and cogs.
Exactly.
If you know the position and momentum of every single Lego brick, you can perfectly predict the future of the entire machine.
But notice the psychological effect this has on the observer.
Oh, it's bleak.
Yeah, if the universe is a clockwork machine, what are you? You are a consciousness locked inside a biological machine, wandering around a larger mechanical universe.
You're totally separate.
You are alienated. You are an isolated observer sitting behind a pane of thick glass, watching the dead universe do its thing.
That sounds incredibly lonely. But, you know, while the West is busy pulling the universe apart into smaller and smaller dead pieces, let's look at the other side of our imaginary room. What is happening in the East?
Well, the Eastern philosophical traditions, and here Capra focuses heavily on Hinduism, Buddhism, and Taoism, they simply never experienced this great divorce.
They never had a Parmenides step in and chop reality into spirit and matter.
Right, they skipped the Lego phase entirely.
Which is so interesting.
They maintained, developed, and deepened that original holistic view. But it's really important to understand that they didn't treat this holism as just a monolith. They explored it through different profound lenses.
Like what?
Well, in Hinduism, for example, there's the concept of Brahman. And Brahman isn't like a bearded god sitting on a cloud. It is the ultimate unifying reality. the divine, infinite ground of all being.
Okay, so it's the underlying fabric.
Yes, and everything we see in the physical world is Maya, which translates to illusion, but more accurately means the illusion of seeing things as separate when they're actually manifestations of the one Brahman.
So to a Hindu mystic, mistaking a tree for a separate, isolated object instead of a temporary expression of Brahman is like the fundamental error of human perception.
Exactly. Now let's look at Taoism. The Chinese sages developed the concept of the Tao, which translates loosely to the way.
Right, the way.
The Tao is the cosmic process, the continuous flow and dynamic, unceasing change of the universe. Reality isn't made of static things, it's made of processes.
It's verbs, not nouns.
Beautifully put. And in Buddhism, particularly Mahayana Buddhism, you have the concept of sunyata, or emptiness.
Emptiness sounds a bit nihilistic, though.
It does, but this doesn't mean a blank void. It means empty of independent existence.
Oh, I see.
A leaf only exists because of the sun, the soil, the rain, and the observer. It has no isolated self.
It's the difference between asking, what is this thing made of, versus how is this thing connected to everything else?
Exactly. And this ancient split in what we believed reality was, it directly caused a massive split in how we tried to understand it.
Because the tools have to match the goal.
Right. If you truly believe the universe is a machine made of parts, you understand it by taking it apart. You analyze it. But if the universe is a seamless, dynamic web of relations, you can only understand it by experiencing your connection to it.
Because you cannot dissect a flowing river without destroying the river.
Precisely.
Which brings us to a major crossroads in Capra's work, which is the map versus the territory. Rational versus intuitive knowledge. Because when you realize that the West and the East spent thousands of years chasing completely different versions of reality, you realize they had to build completely different toolkits for the job.
And Capra points out that humanity essentially has two distinct modes of knowing, two different epistemologies.
Okay, let's break those down.
The first is rational knowledge.
Yeah.
This is the domain of Western science, and it belongs entirely to the realm of the intellect.
The intellect. The part of the brain that just loves to organize and categorize things.
The intellect is the ultimate divider. I mean, the word rational actually shares a root with ratio and ration, which mean to divide, to parse out.
Oh, wow. I never thought of that.
Yeah, the intellect operates by discriminating, measuring, and categorizing. It looks at the continuous flowing reality of the universe and just starts drawing borders everywhere.
It says, this is a plant, that is an animal. This is a solid, that is a liquid. This is the cause, that is the effect.
It builds the Lego sets, it gives everything a label.
And it does this beautifully through mathematics and language.
It does.
Yeah.
But intuitive knowledge, which Eastern mysticism considers absolute knowledge, is completely different. It's entirely non-intellectual.
So it's not about thinking.
No, it doesn't arise from thinking about reality. It arises from a direct experiential seeing of reality. It is a state of consciousness where the thinking mind, the categorizing mind, is completely quieted.
Okay, I have to step in here and push back on behalf of our listeners.
Go for it.
Because if you are raised in the West, you are essentially programmed to believe that the scientific method is the ultimate arbiter of truth.
Absolutely.
So the skeptic listening right now is likely screaming, wait a minute, isn't rational, peer-reviewed science the only truly objective way to know something? How can personal intuition, some feeling you have while sitting on a cushion with your eyes closed, possibly be considered reliable data? Isn't that just subjective imagination?
That is the exact hurdle the Western mind has to clear, and it's why Capra's synthesis is so vital. He explains that science, our rational intellectual process, creates a map of reality.
A map, okay.
Through physics, chemistry, and mathematics, we have created an incredibly detailed, highly functional, beautifully intricate map.
And we like maps. Maps get us to the grocery store. Maps built the James Webb Space Telescope.
Maps are completely necessary for functioning in the physical world. If you want to build an airplane or a smartphone, you need the map.
Right.
But, and this is the crucial philosophical point, a map is merely a symbolic representation of reality. It is not reality itself.
Oh, that's a huge distinction.
The word water will not quench your thirst. The mathematical equation for gravity will not hurt when you fall. Rational knowledge is always a step removed. It is a description.
And a description is not the experience.
Exactly. Mysticism seeks to experience the territory directly.
Yeah.
And to address your skeptic directly, Eastern mysticism actually is deeply empirical.
Really? How so?
It is based on rigorous, repeatable observation.
But without microscopes.
Right. Instead of using microscopes, telescopes, or particle accelerators to observe the outside world, The mystic uses meditation as a finely tuned apparatus to systematically observe the inner world.
To observe the nature of consciousness itself.
Exactly. It is a highly disciplined methodology.
I want to make sure you, the listener, really internalize this difference between the map and the territory, because this was a huge light bulb moment for me.
It's a great concept.
Imagine I hand you a 10-page scientific document that details the exact chemical, molecular, and structural breakdown of an apple.
Okay.
It lists the exact fructose levels, the cellulose structure of the skin, the specific wavelengths of red light reflecting off its surface, the genetic sequence of its seeds. That document is the map. That is rational science.
And it's incredibly detailed, and it's 100% correct.
Right. It gives you a perfect intellectual understanding of the apple. But reading that piece of paper will never, ever give you the sudden, sensory, completely indescribable experience of actually biting into a crisp apple.
Never.
Feeling the snap of the skin, the juice on your tongue, the rush of sweetness, that raw, immediate experience that is the territory. That is intuitive knowledge. You bypass the intellect completely and just experience the apple.
That is a brilliant illustration. The mystic sits in meditation, not to think about the universe, but to directly taste the universe by experiencing their inseparable connection to it.
Wow.
And for centuries, the West was perfectly happy refining its map, making it more and more detailed. We discovered cells, then molecules, then atoms.
We kept finding smaller and smaller Lego bricks.
We did. The map was getting so good, we thought we had the universe completely figured out. We thought we were approaching the end of physics.
But then the map started to tear. And not just tear, it spontaneously combusted.
It really did.
Because as our scientific maps became infinitely more complex, probing deeper and deeper into the microscopic world, physicists hit a terrifying wall. The very tools we use to build our maps, specifically human language, classical logic, and the concept of solid matter, they began to completely fail us.
We entered the 1920s, the golden age of quantum mechanics. You had geniuses like Werner Heisenberg, Niels Bohr, Erwin Schrödinger peering into the subatomic realm, expecting to find the ultimate tiny Lego bricks that Democritus has promised us.
But instead of solid bricks, they found something that defied everything the human brain evolved to understand.
Utterly defied it.
Let's talk about why words literally fail at the subatomic level, because this is where the story of physics turns into, like, a psychological thriller. Let's look at the most famous example from Capra's sources, which is the double-slit experiment and wave-particle duality.
Oh, this is the experiment that drove physicists to the absolute brink of madness.
Let's set it up for the listener.
To understand how reality broke, we have to understand the setup. Imagine a wall with two vertical slits cut into it. Behind that wall is a detector screen, like a piece of photographic film.
Okay, I have the picture in my head. A wall with two gaps and a blank screen behind it.
Now, if you fire solid particles, let's say tiny marbles, representing our Lego bricks at that wall, the ones that make it through the slits will hit the back screen and form two distinct bands, roughly the shape of the two slits.
Makes perfect sense. Two slits, two lines of marbles on the back wall. That is how solid matter behaves.
Exactly. Now, if you instead send a wave of water toward that wall, the wave goes through both slits at the same time.
Right.
The two new waves emerge from the slits, overlap, and interfere with each other. Where two crests meet, they amplify. Where a crest meets a trough, they cancel out.
So on the back wall, this creates a pattern.
Yes, an interference pattern, a series of alternating bright and dark bands spread out all across the screen.
Okay, so just to recap, particles make two bands. Waves make a spread out interference pattern. They're completely different behaviors.
Totally different. Now, the physicists took light, and later single electrons, which are the supposed solid building blocks of matter, and fired them at the double slits one by one.
One by one.
And what built up on the back screen over time was an interference pattern, the pattern of a wave.
Wait, they fired them one by one.
Yes.
So a single electron was somehow going through both slits at the exact same time, interfering with itself, and acting like a spread out wave.
That's what the pattern shows.
So we threw a single Lego brick at the wall, and it went through two holes at once.
It did. The mathematics, formalized by Schrödinger's wave equation, showed that the electron was not a solid point, but a wave of probabilities, a superposition of possible states.
That is insane.
But here is where the universe really breaks our brains. The physicists said, well, this is impossible. We need to see which slit the single electron is actually going through.
Right, let's catch it in the act.
So they placed a detector right at the slits to observe the electron as it passed.
They set up a camera, basically.
Yeah, exactly. They observed it. And the moment they measured it, the electron stopped acting like a wave.
Wait, what?
It went through one slit or the other, hit the back screen, and formed the two-band pattern of solid marbles.
It's a shapeshifter.
It really is.
The very act of looking at it caused it to change its fundamental nature. It acts as a continuous wave when you aren't looking, and a solid, discrete particle when you are.
And this is a logical impossibility in classical physics and classical language. In the everyday world, something cannot be a localized, solid object and a spread-out, continuous ripple at the same time.
The human mind demands that it be one or the other. Our language requires it to be a noun or a verb, an object or an action.
Right. Trying to describe quantum mechanics using everyday English or German or French is essentially like trying to describe the color blue to someone using only musical notes.
That is a perfect way to put it.
You know, you can sit at a piano and play all day long. You can hit all the right keys, play the most beautiful sonata, but you will never actually convey blue.
The vocabulary simply isn't built for it.
It isn't. Our language evolved to describe medium-sized objects moving at medium speeds on an African savanna.
It evolved to help us throw rocks at antelopes.
Exactly. It did not evolve to describe a single electron existing in a cloud of probabilities simultaneously.
I can't even imagine how frustrating that must have been for the scientists.
Oh, this linguistic breakdown caused immense suffering for the early quantum physicists. Werner Heisenberg famously wrote about the intense struggles and frustrations they experienced.
What did they do?
They would stay up until dawn at the physics institutes in Copenhagen, arguing fiercely, trying to force quantum reality into everyday language.
Just going in circles.
Heisenberg described walking alone in the park after these debates, feeling a sense of absolute despair, wondering if nature could truly be as absurd as it seemed to be in their mathematical equations.
Their rational map was screaming that reality was a paradox. They were trying to force the territory to obey the map, and the territory was stubbornly refusing.
And Capra draws a really profound parallel here. Physicists in the 1920s were experiencing a linguistic and logical breakdown that Eastern mystics have been intimately familiar with for millennia.
Because mystics have always known the map isn't the territory. They never expected the universe to fit neatly into a sentence.
Exactly. Mystics have always recognized the fundamental inadequacy of language to describe absolute reality. The very first line of the Tao Te Ching, the foundational text of Taoism, is, "The Tao that can be spoken is not the eternal Tao."
The moment you use a word, you create a boundary.
Yes. If you say God is light, you automatically imply God is not dark. Language functions by dividing the world into opposites. But reality, the physis, the Tao, unites them.
So how do the mystics deal with it? If they know they can't speak about it directly, what is their equivalent of quantum mathematics? How do they communicate the truth without breaking it?
They use paradox deliberately. They use language to sabotage language.
Oh, that's clever.
Look at the Zen Buddhist tradition. They use koans. These are short riddles or stories given by a master to a student that have absolutely no logical answer.
Like what?
The most famous one is, what is the sound of one hand clapping?
Ah, right. And when you hear that, your brain immediately tries to solve it. You think of the sound of fingers snapping or a hand waving through the air or slapping your leg.
But none of those are the answer.
Because there is no rational answer.
Exactly. The entire purpose of the koan is to exhaust the intellect. It forces the rational, categorizing mind to run into a brick wall so hard that it temporarily shuts down.
It short-circuits the brain's need to label.
Yes. And in that moment of intellectual silence, the intuitive mind can finally experience reality directly.
It's an ancient neurological hack.
It really is. Similarly, in the ancient Hindu texts, the Upanishads, when sages tried to describe the absolute reality, the Brahman, they used the Sanskrit phrase neti neti.
Which translates to, not this, not that.
Right. They refuse to categorize it.
Yeah.
Whatever you think reality is, it's not that. If you think it's a particle, it's not that. If you think it's a wave, it's not that.
It forces the human mind beyond logical categorization.
And what Capra points out so beautifully is that quantum physicists, looking at the detector screens, were accidentally stumbling into the realm of neti neti. Is an electron a particle? Not exactly. Is it a wave? Not exactly.
The universe was forcing physicists to become mystics.
Basically.
Because if language and common sense were breaking down, it was because the foundational rules of Newton's clockwork universe were actively being shattered. The stage itself was collapsing. which catapults us into our next major shift, which is shattering the clockwork universe through relativity.
If quantum mechanics dismantled the idea of solid Lego bricks, Albert Einstein's theories of relativity dropped an absolute bomb on the table the Lego bricks were resting on.
He dismantled the very stage upon which the universe plays out, space and time.
Yes, he did.
Let's step back into Newton's world for a second to truly appreciate what Einstein destroyed. In the Newtonian universe, space is just an empty, rigid, three-dimensional box. It's the empty stage where the actors, the atoms, do their thing.
And time is a separate, absolute ticking clock hanging on the wall of that stage. A second is a second, everywhere in the universe, for everyone, forever.
It is entirely objective and independent of whoever is experiencing it.
But in 1905, with special relativity, and later in 1915 with general relativity, Einstein fundamentally obliterated that view. He proved that space is not a rigid box and time is not a separate universal clock.
So what are they?
Instead, they are intimately, inextricably fused together into a single four-dimensional continuum, which we call space-time.
Okay, let's do a thought experiment, because we promised to explain the how and the why. How does time actually bend?
Imagine Einstein's famous train thought experiment. Imagine you are standing on a train platform, and a train zooms by you at near the speed of light.
Okay, I'm on the platform.
Inside that train is a light clock, a photon of light bouncing up and down between two mirrors. For the person on the train, the light just goes straight up and straight down. Tick-tock.
Okay, straight up and down from their perspective.
But for you, standing on the platform watching the train zoom by, the light doesn't just go up and down. Because the train is moving forward, the light has to travel in a diagonal zigzag path to hit the mirrors.
Right, because the mirror moved forward while the light was traveling, so the light has to cover a longer distance from my perspective on the platform.
Exactly. And since the speed of light is absolute and can never change, if the light has to travel a longer distance, it must take more time to do it.
Oh, wow.
Therefore, from your perspective on the platform, the clock on the train is ticking slower.
Wait, so the clock isn't mechanically broken? Time itself is passing slower for the person on the train relative to the person on the platform.
Yes. Time is relative to how fast you are moving. There is no universal now. My now could be your past or your future, depending on our relative speeds.
That is wild. And then general relativity brings gravity into the mix. Think about the room you are sitting in right now listening to this. You probably think of it as an empty box holding you, your furniture, your phone.
But relativity tells us that space is not empty nothingness. It is more like a flexible, invisible trampoline.
The trampoline analogy is so good.
It really helps. Imagine placing a heavy bowling ball, representing a massive star or a planet like Earth, onto that trampoline. The fabric of the trampoline bends and warps around the mass.
So it creates a dip.
Yes. And that bending, that curving of space-time itself, is what we experience as gravity.
So gravity isn't an invisible magnetic rope pulling an apple to the ground. The apple is just falling down the slope of curved space created by the Earth's mass. And because space and time are fused, time bends with it. A clock on the surface of the Earth literally ticks slower than a clock deep in outer space.
And this brings us to perhaps the most famous scientific equation of the 20th century, which emerged from relativity, the equivalence of mass and energy. E equals mc squared.
Energy equals mass times the speed of light squared. We print it on coffee mugs and t-shirts, but what does it actually mean for our view of reality? How does mass become energy?
Let's look at nuclear physics. The c in that equation is the speed of light, a massive number.
Yeah.
And you square it, making it astronomically huge.
Right.
This equation tells us that a tiny, tiny amount of mass contains a staggering, almost incomprehensible amount of bound energy.
Like an unimaginable amount.
In nuclear fission, when we split a uranium atom, we lose a tiny fraction of its mass. Where does that mass go? It converts into energy.
Ah, I see.
That tiny missing mass is what levels a city in an atomic blast or powers a nuclear submarine for decades.
Hold on, so if mass is just bound energy, why does a rock feel heavy? Why does it feel solid?
It feels solid because the energy is bound up in incredibly tight dynamic patterns. What you perceive as mass is just the energy required to hold those subatomic particles together.
So matter is not a static thing.
No, it is a form of energy, and energy is inherently dynamic. It is an activity, a continuous process.
So if I pick up a rock, I'm not holding a dead, solid object. I'm holding a concentrated vortex of raging cosmic energy.
Precisely. The cosmos went from being a predictable, dead machine made of solid parts to a highly dynamic, ever-changing dance of energy.
There is no absolute objective viewpoint in the universe.
Yeah.
Everything space-time mass is relative, fluid, and dynamic.
The universe isn't a museum we are walking through. It's a continuous performance, and we are on the stage.
I love that. And this realization mirrors the Eastern mystical tradition so profoundly.
It does. Buddhists have always taught the concept of impermanence, that nothing has a solid, fixed, independent substance. Everything is in a state of constant flux and transformation.
It's all moving.
But perhaps the most beautiful parallel Capra draws is with Hinduism, which pictures the universe as the cosmic dance of Shiva, the Nataraja.
Oh, the dancing figure.
Yes. Shiva dances the universe into existence, sustains it, and destroys it in a rhythmic, eternal cycle of energy. Capra says that modern physics has mathematically proven the cosmic dance of Shiva. Every subatomic particle is engaged in an unceasing, pulsating dance of energy.
Relativity merged space and time, and it merged mass and energy. It melted the rigid boundaries of the Newtonian world. But as wild as relativity is, it was quantum theory that ultimately delivered the fatal blow to the old scientific worldview.
It really was the nail in the coffin.
Because quantum theory forced science to merge the observer with the universe itself.
This is where we reach the absolute peak of Capra synthesis. We've established that the universe is a dance of energy, but human beings still tend to think of themselves as separate from the dance.
We think we're sitting in the audience watching it happen.
Exactly. But quantum physics proves that the audience does not exist.
Yeah.
Everyone is on the dance floor.
Let's delve back into the bizarre reality of subatomic physics to see how we got here. In the early 20th century, physicists finally cracked open the atom. And what did they find? Nothing. Well, almost nothing.
They found that atoms are vastly, overwhelmingly composed of empty space.
How empty?
If you imagine the nucleus of an atom, the protons and neutrons as a tiny grain of sand sitting right on the 50-yard line of a massive football stadium, the electrons are like tiny gnats buzzing around the absolute outer edges of the top bleachers.
Wow.
Everything in between the grain of sand and the gnats is just completely empty space.
Okay, I have to push back here again.
Let's hear it.
If you are telling me that atoms are 99.99% empty space,
Yeah.
and my desk is made of atoms, and my hand is made of atoms, why doesn't my hand go right through the desk?
It's a fair question.
If I knock on my wooden desk right now, it feels incredibly solid. How can the universe be a blur of empty space if I can literally stub my toe?
This is where we have to fundamentally rewrite our sensory understanding. Let's look at the mechanism.
Okay.
The desk feels solid, not because it is filled with hard matter, but because of electromagnetic repulsion and something called the Pauli exclusion principle.
What does that mean in plain English?
The electrons in the atoms of your hand have a negative charge. The electrons in the atoms of the desk also have a negative charge.
And charges repel each other, right? Like the wrong ends of two magnets.
Exactly. When you bring your hand close to the desk, those electron clouds violently repel each other. They refuse to overlap.
Ah, I see.
When you knock on the desk, you are not feeling solid stuff hitting solid stuff. You're feeling a localized force field of energy in your hand, resisting another localized force field of energy in the desk.
Wait, so you're telling me I've never actually touched anything in my entire life? I'm just hovering a fraction of a nanometer above my chair right now, suspended by magnetic levitation.
You are. The sensation of touch is just your brain interpreting the electromagnetic resistance between energetic fields.
That is just...
Mind-blowing. Yeah, completely. Mind-blown. The Lego bricks are a complete illusion created by our macro-scale sensory organs.
But it gets stranger. When we look at those tiny subatomic particles, the electrons we find, they don't even exist with absolute certainty.
What do you mean?
In classical physics, a planet is at a specific place at a specific time. But as we saw with the double-slit experiment, an electron does not exist at a definite place. It exists as a tendency to exist. It is a field of probability.
A tendency to exist. It might be there, it might not.
Until you look at it. And this is the great quantum revelation, the observer effect.
Okay, listeners, lean in because this is the craziest part of modern science.
At the quantum level, the act of observing fundamentally changes the reality of what is being observed. We mentioned earlier that an electron exists as a wave of probability, a superposition of potential locations, until a scientist sets up an instrument to measure it.
Right, the camera at the slits.
The very instant the measurement is made, the wave function collapses, and the electron is forced to take a definite localized state. The particle isn't real in a specific location until we force it to answer the question, where are you?
Exactly. The human choice of how to set up the experiment, whether to look for a wave or a particle, literally determines the physical reality the particle takes on.
So what does that mean for us?
Therefore, the concept of a strict, objective, independent observer is a total myth. You cannot look at the universe from behind a safe pane of glass. The act of looking breaks the glass and interacts with the room.
We are hopelessly, fundamentally entangled with reality. We are pulling the strings just by opening our eyes.
As the brilliant physicist John Wheeler phrased it, we must replace the word observer with the word participator. We live in a participatory universe.
A participatory universe.
Reality is not a given. It is co-created by the observer and the observed. And here's the grand synthesis that Capra presents. Modern physics has scientifically, mathematically, and experimentally proven what Eastern mystics claimed thousands of years ago.
That the concept of a separate, isolated self is an illusion.
Yes. The illusion of separation is the root of human suffering in Buddhist and Hindu philosophy. The Buddha taught the concept of dependent origination, that all phenomena arise together in a mutually interdependent web of cause and effect.
So the idea that you are a discrete, separate ego, locked inside a meat suit, looking out at an alien, disconnected universe, is mathematically and philosophically false.
It's completely false. You are not a drop of water in the ocean. You are the entire ocean expressing itself as a drop.
I want to directly challenge you, the listener, right now. Take everything we've talked about and apply it to your own physical body.
It's a great exercise.
When you walk down the street, you probably feel like a discrete, isolated object wandering through a world of other objects. But quantum physics and ancient mysticism are begging you to change that map.
So how should they view themselves?
Try viewing your body not as a solid statue, but as a localized whirlpool in a fast-moving river.
A whirlpool.
Yeah, the whirlpool looks like an object, but it's really just a pattern of water constantly flowing through. You are a temporary, highly concentrated vortex of energy.
That is so accurate.
With every breath you take, with every bite of food, with every photon of light hitting your skin, you are in a massive, constant, unstoppable exchange of energy with your environment.
The carbon atoms currently in your lungs were inside a tree yesterday.
Exactly. The water molecules in your blood were in a cloud last week. You are not in the universe. You are the universe actively occurring.
And that is the exact territory the mystic experiences in deep meditation. They quiet the rational, categorizing mind. They stop chopping the world into me and not me, and they directly experience that energetic exchange.
They feel the reality of the participatory universe.
Modern physics took the longest, hardest, most mathematically rigorous paths imaginable. Splitting atoms, building massive particle colliders, deriving complex relativity equations, only to arrive at the exact same mountaintop that the mystics have been sitting on for 3,000 years.
It is the most beautiful full circle moment in human intellectual history. And that brings us to the end of our deep dive. Let's recap this incredible journey we've just been on.
We started in ancient Greece, watching philosophers like Parmenides fracture a unified, living world into a binary of spirit and dead matter.
We watched Democritus turn that dead matter into the giant bucket of Lego bricks, which Newton then built into a rigid, mechanical, clockwork universe.
We saw how that mechanical map became so microscopically detailed that it broke the tools we used to build it.
We hit the limits of human language and classical logic in the 1920s, struggling with paradoxes like wave-particle duality that echoed the ancient Zen koans and the Hindu concept of neti-neti.
We rode with Einstein on his train as he warped space and time into a single trampoline, proving mathematically that mass is just dancing energy.
And finally, we plunged into the quantum realm, discovering that the universe is not a collection of solid objects, but a vast web of interacting probabilities, a web that fundamentally requires our conscious participation to exist.
Modern science, armed with the most advanced technology in human history, essentially rediscovered the ancient Eastern truth that everything is fundamentally interconnected energy in motion.
Which forces us to ask very deep, intimate questions about our daily experience.
It does. And that brings me to a final thought I want to leave the listener with. Something to mull over as you go about your day.
Lay it on us.
We've established that quantum mechanics insists that the observer inherently alters the reality being observed.
Right.
At the subatomic level, your act of looking forces the universe to make a decision to collapse the wave function. Now scale that up. You are a conscious being and you are constantly observing the world around you every waking second of your life.
Every single moment is an observation.
So are you merely walking through a pre-existing universe that is already painted, finished, and solid? Or if the universe requires a participator, is your consciousness actively co-creating reality in real time, step by step, just by the simple act of experiencing it?
Oh, wow. Are we painting the road as we drive on it?
It is a profound possibility suggested by the overlap of these two great traditions.
I love that. And it brings us right back to where we started today. Remember that broken arm, that clean, precise X-ray that we all find so comforting?
The binary diagnosis.
Yeah. What we've learned today is that if you zoom in close enough on that jagged white line, the bone disappears. The Lego bricks dissolve. The solidity vanishes.
The X-ray dissolves into a swirling, interconnected cosmic dance of energetic probabilities.
The diagnosis of reality is murky, yes. But it turns out that murkiness isn't a flaw in our vision. The fluid, boundless, interconnected mystery is the masterpiece itself.
Beautifully said. The territory is waiting to be experienced.
Thanks for taking this incredible deep dive with us today. Keep looking closer.